Okay, imagine this. You've got a dinosaur, right? Late Cretaceous Argentina. It's a predator, pretty big.
Mm-hmm.
But its arms are, well, they're almost gone. And the hands, barely any fingers.
Sounds pretty weird.
It does. But that's Aucasaurus. And today, we're going to really get into what makes this dinosaur just so fascinating.
Yeah, absolutely. We're doing a deep dive into Aucasaurus garridoi, looking at the science behind it,
Right.
the discovery papers, anatomical studies, how it fits in the family tree, all that good stuff. The plan is really to pull out the key details, understand why it's such a standout.
Okay, let's start at the beginning, the discovery. This was in the Anacleto Formation in Argentina.
That's right, late Cretaceous period. We're talking Santonian to Campanian stage.
A long time back.
A very long time back. And the main specimen, the holotype, that was found in the Rio Colorado subgroup.
And that area, the Nuquien Basin, is pretty significant, isn't it?
Oh, hugely significant. It's like a treasure trove for paleontologists. Loads of dinosaur fossils, even sauropod eggs, gives you a real picture of the whole ecosystem.
Oh.
And what really made this particular find back in 2002 such a big deal was just how much of the skeleton they actually found.
Yeah, I read that it was complete all the way to the 13th caudal vertebra. Now, remind me, what's a caudal vertebra?
It's just a tailbone, one of the bones making up the tail.
Okay.
And finding a skeleton that complete, that's incredibly rare. It gives us a much, much better idea of the animal's actual shape, its proportions.
So, a game changer for understanding this group.
Definitely. At the time, it was the most complete Abelisaurid skeleton known. Abelisaurids being the specific family Aucasaurus belongs to.
Must have been amazing for the researchers, like finally getting a really good look.
Exactly. A fantastic opportunity. And we also know from analyzing the bones later on that this specific animal was mature.
Oh, really? How old?
At least 11 years old when it died.
How do they figure that out? Like tree rings?
Pretty much, yeah. Studying the bone microstructure can tell you about growth patterns and age. And having a complete mature specimen, that's gold for understanding the adult form.
And there was something else. A bit traumatic. Some damage to the skull.
Ah, yes. There was some damage.
Leading to speculation, maybe a fight before it died? Like a dino cold case?
Well, speculation is the right word. We can't know for sure what caused it. But it does spark the imagination, doesn't it?
It really does.
Reminds you, these weren't just fossils. They were living animals in a dangerous world. Competition, predators, the usual.
Right. Okay, so let's picture this Aucasaurus. Size-wise, what are we talking?
Medium size for an abelisaur, around 5.5 to 6.2 meters long.
So maybe 18 to 20 feet?
Yeah, about that. And weighing roughly 700 kilos, maybe 1,500 pounds. And, substantial, but not the absolute biggest predator around.
Smaller than Carnivores, for instance.
Definitely smaller than carnivores. And its skull was different, too. Not as short and deep,
And no horns? Carnivores had those famous horns.
Right. Aucasaurus didn't have those. Instead, it had these low, bony ridges above the eyes. A different look.
But the arms, that's the really wild part, isn't it?
Oh, absolutely. The forelimbs were incredibly reduced. Tiny.
Even more reduced than Carnotaurus, proportionally.
Yes, exactly. Because Aucasaurus itself was smaller, the arms look even tinier relative to its body. It's like evolution just wasn't interested in arms for this guy.
And the hands.
Yeah.
Tell me about the hands.
Okay, so this is where it gets really interesting. It had 4 metacarpals. Those are the bones in the palm.
Uh-huh.
But the first one and the fourth one, no fingers attached. None at all.
Seriously? Just palm bones?
Pretty much. And the middle two, the second and third metacarpals, they did have fingers, but they were short.
Okay.
And this is key, they didn't have any claws.
No claws on a predator.
No claws. Which really makes you rethink things, doesn't it? We tend to picture theropods using arms and claws to grab prey.
Yeah.
But Aucasaurus clearly wasn't doing that. Suggests a totally different hunting style.
So what was it doing? Did the tail give any clues? I read something about the tailbone suggesting strong muscles and rigidity.
That's right. The caudal vertebrae show features that point towards significant musculature. And a stiff, powerful tail like that, it could have acted as a counterbalance. Running fast, high speeds, quick turns, stability. It points towards an agile predator.
Maybe relying on speed and its bite rather than grappling with its arms.
That seems like a very strong possibility, yes. Speed over strength in the forelimbs.
Fascinating. Okay, let's move up to the head. There was that 2015 study using CT scans, right?
Yeah.
Peeking inside the skull.
Yes, that was a great study. CT scanning technology has been revolutionary for paleontology. It lets you sort of digitally dissect the fossil without damaging it.
So they got a 3D view of the brain case
Yeah.
and the inner ear.
Exactly. They created virtual endocasts, models of the brain cavity, and models of the inner ear labyrinth.
What did that show? Anything surprising?
Well, the overall structure of the brain, forebrain, midbrain, hindbrain, looked quite similar to other abelisaurids like Majungasaurus and Indosaurus. So, some common ground there.
Okay, shared features within the family.
But there was a unique feature too, something called the floccular process.
Floccular process, what does that do?
It's part of the cerebellum, involved in balance, coordinating eye movements with head movements, that kind of thing. Important for stabilizing gaze.
And what was special about it in Aucasaurus?
It seemed relatively larger compared to, say, Majungasaurus, and it sat inside this distinctively shaped recess, kind of like a figure eight.
A larger flocculus, maybe related to needing better coordination,
Hmm.
tying back to the fast runner idea.
It could well be. Better balance control, better gaze stability. It all fits with the picture of an agile predator needing precise movements. The eight shape is more just a specific anatomical detail that helps identify it.
Interesting. And the study also mentioned something about head movement, that Patagonian abelisaurids like Aucasaurus could move their heads more freely.
Yeah, a slightly wider range of motion compared to some other groups. Again, tiny details, but they all add up to build a picture of how this animal moved and interacted with its environment.
And the inner ear itself, similar to Majungasaurus.
Broadly similar in shape and size, yes. But there was one difference. The lateral semicircular canal.
Part of the balance system.
Exactly.
Yeah.
It was a bit shorter in Aucasaurus. The exact functional implication of that small difference is still something scientists are figuring out, but it shows these subtle variations even among close relatives.
Okay, this next bit is really interesting. Kind of prehistoric medical issue. The fused tailbones.
Ah, the pathology, yes. In the main holotype specimen, the fifth and sixth caudal vertebrae tailbones were fused together.
Just stuck. Not meant to be like that.
No, definitely not typical. And a study, quite recently actually, looked into this.
And what did they conclude?
They interpreted it as a congenital disorder, something it was born with, a condition called block vertebrae.
Block vertebrae.
Yeah, it's where the vertebral segments just don't separate properly during development, so they end up fused, a kind of birth defect.
Wow. And that's significant
Because it seems to be the earliest known example of this specific condition in a non-avian theropod fossil.
So we're seeing evidence of dinosaur diseases or developmental issues from millions of years ago.
Exactly. It's not just about how they typically looked, but also the individual challenges they faced. Gives you a different kind of connection to these animals.
Absolutely. Okay, let's put Aucasaurus in context. Its place in the family tree.
Mm.
There was some initial confusion.
Right?
Maybe it was the same as Abelisaurid.
There was some discussion about that, yeah. Back in 2009, one researcher suggested Aucasaurus gyrodoi might just be a junior synonym of Abelisaurid comahuensis. Someone even formally renamed it Abelisaurid gyrodoi briefly.
But that didn't stick.
No, the consensus now, based on looking really closely at all the anatomical details, is that they are distinct genera. Related, yes, but separate.
So where does it fit now? Closer to Carnotaurus.
That's what more recent studies suggest. Aucasaurus and Carnotaurus seem to be quite closely related, often grouped together in a tribe called Carnotaurinae.
Carnotaurinae.
Ah.
Okay. And we have sources showing cladograms, those family tree diagrams.
Right. Those analyses place Aucasaurus firmly within Carnotaurinae. And that tribe, Carnotaurinae, is part of a slightly larger group, the Carnotaurinae subfamily.
Which includes other cool abelisaurids.
Oh, yeah. You've got Majungasaurus in there, Illicolesia, Scorpiovenator, Acrixonatosaurus, a whole rogues gallery of southern hemisphere predators from the late Cretaceous.
Quite the family reunion.
It really shows you the diversity and the evolutionary relationships within this important dinosaur group, the Abelisauridae. And remember, it all ties back to that location.
The Nanocludo Formation.
Exactly. The youngest formation in the Nucan group, part of the Rio Colorado subgroup. That geological context is crucial for understanding when these dinosaurs lived and what other creatures shared their world.
Okay, so let's wrap this up. Our deep dive into Aucasaurus. We've seen this medium-sized predator from Argentina. Its claim to fame, really, is that amazing skeleton.
The most complete abelisaurid found at the time.
Revealing those incredibly tiny finger-four clawless arms. Just bizarre.
Really bizarre.
And the skull with ridges, not horns. plus insights from inside the brain case suggesting agility.
And even evidence of a birth defect, that fused tail vertebrae.
Right, and we've placed it firmly in the family tree, a close cousin to Carnotaurus within the Carnotaurine tribe.
It's a dinosaur that really challenges our assumptions about what a successful large theropod needed, doesn't it? Especially regarding forelimbs.
It absolutely does. Which leads to a final thought for you to ponder.
Yeah.
Those arms. Seriously reduced, no claws for grasping. What does that really tell us about how Aucasaurus hunted and lived? Could speed and agility, hinted at by the tail, truly compensate entirely for basically having no useful arms? And given how well preserved that first skeleton was, what other secrets might still be buried out there in Argentina waiting to tell us more about this strange and fascinating dinosaur?